Welcome back, and in this video we're going to be moving on to look at naming organic molecules. We're going to be starting with the alkanes, but we'll also introduce a few more functional groups to you that you're going to need to learn. The first time you come across naming organic molecules, it can be a little bit confusing, but you'll need to learn to break it down into steps. And that's what we're going to go through in this video. So at GCSE you probably learnt the names of the simple alkanes. So pause the video at this point and see how many you can remember up to carbon 10. So hopefully most of these should be familiar to you. But you will need to understand that these names can be broken down, if you like, into two parts. The first part, meth, for example, gives you the number of carbon atoms present. The second part of the name, ANE, tells me the functional group that I'm dealing with. So you should notice that all of these end in ANE. That tells me that they belong to the homologous series of the alkanes, and they all have the same functional group. So, in terms of rules for naming things, the first thing you need to do is identify the longest chain of carbons, and that's going to give you the prefix of the name of the molecule. So meth tells me I've got one carbon in my chain. Oct tells me I have 8 carbons in my longest chain, and you do need to learn these. So if the prefix gives us the number of carbons in the chain, the second part of the name refers to the functional group, the homologous series to which the molecule belongs. Now, just to be confusing, halogenalkanes have a prefix to the name as well, and they can be thought as a halogen and an alkane. So if we take the homologous series of the alkanes, they may end in ANE. Tells me they belong to the alkanes. The alkenes end in ENE. That tells me it's an alkene. The halogenalkanes, well, they start with chloro, bromo, or iodo to recognize which halogen we're talking about, and because they're halogenalkanes, they still end in ane, A-N-E. Alcohols end in O-L, alcohol. Some ones you might not have come across before, aldehydes and ketones. Aldehydes end in Al, ketones end in O-N-E. Carboxylic acids, which you may be familiar with from GCSE, end in anoic acid. So here are my 3 examples. I have ethane, ethene, and chloroethane. They all start with eth because they have 2 carbons in their longest chain. So eth tells me the number of carbons in the chain. This end of the word here tells me that this belongs to the alkane family. This belongs to the alkene family. This one is a chloroalkane, and it belongs to the halogenalkane family. These other ones you'll come across in later topics. So once we've sorted out the number of carbons in the longest chain and the functional group that is present, we need to number the carbon chain. We always number them starting from the functional group, and we always number them so we get the smallest possible numbers. So, for example, in this first example, this is carbon number 1. That's because this is the carbon with the OH group on it. In this case, this is carbon number 1, and this is carbon number 2. That's because the branch needs to sit on the lowest possible number. So this becomes 2-methylbutane rather than 3-methylbutane. And this molecule is butan-1-ol, not butan-4-ol. What you should also notice is this molecule here is a branched molecule. So I need to show in the name that it has a branch, and I do that by using methyl as a prefix. Now these side chain or branches off of the main straight chain of carbons are called alkyl groups, ALKYL groups. That's because we're adding an alkyl. An alkyl is an alkane, which is minus a hydrogen atom, and this just allows it to bond onto the main carbon chain. And again, the name refers to the number of carbons in the branch. So meth tells me there is one carbon, YL on the end tells me it's an alkyl group, it's a branch onto the main chain. So we there have everything up to hexyl. And the molecular formula, same idea, we've got the formula, we've got a line representing where it is bonded on to the main carbon chain. Last but not least, we need to indicate the number of each type of alkyl branch. So if you have two branches of the same type, we call it di. So we have 2,3-dimethyl pentane. So if we break that down a bit, pent means 5 carbons. So pentane means I have a backbone of 5 carbons and it's an alkane functional group. Methyl means that there is a branch with 1 carbon on it. Di means that there are 2 methyl branches. 2, 3 indicate the position of those methyl branches on my pentane backbone. So if we look at drawing that first example, 2,3-dimethyl pentane. So we're going to start with the pentane. So that's 5 carbons in a straight chain. I'm not going to put the hydrogens on for the moment. I'm just going to look at the carbon chain for the minute. So I've got 5 carbons. It's pentane, so there's no carbon-carbon double bonds, no other functional groups. I have 2,3-dimethyl. So it doesn't matter which end I count from as long as I'm being consistent in this case. So I have 1, 2, so I've got a methyl group on that second carbon, and I've got a methyl group on this third carbon. It doesn't matter if they're both up or both down, because these are single bonds, so I can rotate around them. So that's my carbon skeleton. What I now need to do is add in the hydrogens. And there's my completed displayed formula with all the carbon-hydrogen bonds showing. It's quite a long time to draw that out. That's why skeletal formulas are often easier. So to draw the skeletal formula for this one, I've got 5 carbons in a chain. So that's going to be 1, 2, 3, 4, 5 carbons. And then on my second carbon, I have a branch. And on my third carbon, I have a branch. And that's quite often why you'll see skeletal formulas drawn, because they're much quicker to do. So we're on page 9 of your notes, and we're just going to have a go at drawing and writing out the names of some organic molecules. So we're going to look at this one first of all. Now the first thing to identify is the longest carbon chain. So I've got 1, 2, 3, 4, 5, 6. So however I draw this, I've got 6 carbons in my longest chain. So that is hex, H-E-X. There are no carbon-carbon double bonds, there's no other functional groups, so it's hexane. So that is my longest chain. I now need to talk about these branches. They're all methyl branches because they all contain 1 carbon, and there are 4 of them. So it's tetra, T-E-T-R-A, methyl hexane. I need to tell whoever is drawing the molecule where those 4 methyl groups are, and I've got 2 on the second carbon and 2 on the 4th carbon. So this is 2, 2, 4, 4 tetramethyl hexane. So the next example, this one, again, we have to identify the longest chain. Now you do need to be a little bit careful because you've got to remember that these chains can go round corners because these are single bonds, they can rotate freely. So you have to find the longest chain of carbons. And in this case, this is my longest chain. So I have 1, 2, 3, 4, 5, 6, 7, 8 carbons in this longest chain. 8 carbons is oct, and there are no carbon-carbon double bonds or any other functional groups, so this is based on octane. This time I have 2 branches, but they are different branches. I have this branch here, which is a methyl branch, and I have this branch here, which is a propyl branch. Again, I'm going to number them, so I've got the smallest possible numbers. So this is 3, this is carbon number 3, and this is carbon number 4. So this would be 3 methyl, 4 propyl, propyl octane. So the last 2, again, I need to identify the longest chain, and in this case, this is my longest chain. So I have 1, 2, 3, 4, 5, 6, 7 carbons. So it's based on heptane. I've got 3 branches. Again, they're all methyl branches. So it is trimethyl heptane. The methyl groups are on positions number 3 and 4. So that's 3, 3, 4 trimethyl heptane. Again, another example here, we need to be careful because it can go round corners. So this again is my longest chain. So I've got 8 carbons in that chain. So again, it's based on octane. I've got 2 branches. I've got a methyl group and an ethyl group. Again, numbering them so you get the smallest possible numbers. This is 3 ethyl, 4 methyl octane. So on the next couple of pages, we'd just like you to have a go at drawing out those molecules. So pause the video at this point and have a go at drawing the structural, displayed and skeletal formulas. Remembering when you drew the structural formula, you read the molecule left to right across the page. It's sometimes easier to start with the displayed formula and then do the skeletal and the structural. So that finishes this video just looking at naming organic molecules. So you'll practice lots of these in class, but you need to get comfortable with naming organic molecules and being able to draw them up to and including C10. In the next video, we're going to be going on and looking at the alkanes in particular. But until then, take care, stay safe, bye-bye.